Could anyone tell me what orbiter is this? This is Mars Climate Orbiter. In September 1999, Mars Climate Orbiter has been lost in the deep atmosphere of Mars due to a software bug that mixed it up between the British and metric units. And this caused a navigation error that led to losing this orbiter forever, along with $327 million of dollars. That was the cost of the program. This story, along with many other stories, tells us and shows us how can software testing change the history of sciences, spaces, organizations, and nations. That's why I'm here today to tell my story about load testing, a history-making system. My name is Day1Bahaa. I'm a principal technical consultant in an Egyptian gold LM partner that is called CompuFairs in Egypt. As well, I work as an associate professor in Faculty of Computers and Information, Helwan University in Cairo, Egypt. I'm a PhD of computer science, MVP for LM since 2007, RD with a Gold Impact Award, and regular speaker for Microsoft in public events such as TechEd, and ISO Advisory Committee member. So let us, to begin the story from the early beginning. Could anyone tell me what is this? This Tahrir Square, yes, you are correct. Yeah, while celebrating Mubarak stepping down in February 11th, 2011. So let us get from the early beginning. In January 25th, Egyptian people protested, asking for freedom and social justice. And one of the major reasons for this revolution was the fake elections that took place 90 days immediately before the revolution. In January 28th, the number of protesters increased massively, and at the end of the day, Mubarak's political party the fake elections have made to it has burned down, and this was the first sign of that the regime is falling down. Due to that, Mubarak commanded the army to impose a curfew and restore order, and the army responded to this command, but they refused to harm people and declared explicitly that they support people's call for freedom and social justice. Every kind of Egyptian man or woman, Muslim, Christian, believer, non-believer, everyone has been united in this revolution, and people slept in the streets trying to protect their homes, shops, companies out of the absence of policemen who tried to punish Egyptian people for this revolution. After 18 days, General Omar Suleiman, the former vice president of Egypt, declared that Mubarak is stepping down, responding to people's call, and delegating the responsibility to the Supreme Council of Armed Forces, or SCAF. SCAF accepted this responsibility patriotically and declared a very clear roadmap for a transitional period that ended up with electing a new Egyptian president. Finally, it has been said that 58 murders have been killed during those days, including my dear student, Karim Bannouna, who used to be my faculty student. At the end, President Obama spoke.
There are very few moments in our lives where we have the privilege to witness history taking place. This is one of those moments. This is one of those times. The people of Egypt have spoken, their voices have been heard, and Egypt will never be the same. By stepping down, President Mubarak responded to the Egyptian people's hunger for change. But this is not the end of Egypt's transition. It's a beginning. I'm sure there will be difficult days ahead, and many questions remain unanswered. But I am confident that the people of Egypt can find the answers and do so peacefully, constructively, and in the spirit of unity that has defined these last few weeks. For Egyptians have made it clear that nothing less than genuine democracy will carry the day. The military has served patriotically and responsibly as a caretaker to the state, and will now have to ensure a transition that is credible in the eyes of the Egyptian people. That means protecting the rights of Egypt's citizens, lifting the emergency law, revising the Constitution and other laws to make this change irreversible, and laying out a clear path to elections that are fair and free.
Elections that are fair and free was the main people call, and we knew at those days that we will live very hard days. But we had to choose between keeping our dignity and restoring our freedom, or to use the very easy way to not protest again. We are living nowadays very hard days, but they are very cheap price for the genuine democracy that we were seeking of. That's why SCAF, or Supreme Council of Armed Forces, has declared 3 phases roadmap. The first phase took place a month immediately after the stepping down that took place in March 2011, which was the transitional constitutional referendum. And the main challenge that we have faced during this referendum, that no one knows where to go to post his vote, simply because no one used to get to voting centers, simply because nobody cared about that before. So as a maneuver action, the Supreme Committee of Elections, which is a standalone committee of superior judges, decided to let any voter to vote anywhere. And surely this was not the best case, but this was maneuver to carry the situation. That's why before beginning the phase 1, which was the parliamentary elections, the Supreme Committee of Elections decided to build a web-based online system that helps people to understand about the procedures of the elections. Additionally, it helped people to post their national ID, which resembles Social Security number here in the States, and to get the voting center address and a plotted location for it over the map. The problem that we faced during this phase was the unexpected users load and the unexpected contribution level of females, wives, and households. That's why, unfortunately, the system scalability was not that good, and it failed to accomplish the mission correctly. That's why before the last phase, which was the presidential election, we decided to take this challenge this time very seriously, simply because it was a matter of life or death for this nation. So the Supreme Committee of Elections decided to build 2 systems. The first one was the web-based online system, to rebuild it again from the early beginning. And we expected, as I will explain later, 95,000 simultaneous users for that system, and I will tell how we calculate this. Additionally, a new system has been built, which was WinForm system or desktop system that calls at the back end WCF, a collection of WCF services. And we expected that the simultaneous load for that system will be 50,000 simultaneous users, simply because this system has been built to establish a communication channel between the Supreme Committee of Elections and each judge that controls a single voting center. It was expected that at the end of the day of the presidential election day, all 15,000 judges will get to this WinForm system in a predefined secret moment to post their result in one moment. And this gave us a simultaneous users expected load of 15,000 users. Luckily, the elections has gone through successfully, and all international organizations, including President Carter Foundation, declared that the results are acceptable. By the way, those are my kids, Baha and Omar. While I passed to them my voting card to place it into the voting box. And this was a common practice that lots of fathers try to do to teach their kids from the early beginning of their lives that this is your right and you have to take it forever. The name of the game for such system was to have a serious, scalable, and reliable systems. And to assure the scalability and reliability of those systems, a very serious load testing has to be established. And actually, we have documented this load testing experience in a 5-star Microsoft success story that I will point for the address at the end. So before getting to my story, I would like to review with you some important terminologies about performance testing, load testing, stress testing, and some other kinds of testing. So performance testing is trying to answer one of the very important questions, which is how responsive your system is. And this actually is core part of the performance engineering practices. To answer such kind of question and to apply whatever kind of subsequent load tests, you have to make sure as a prerequisite that your system can run in a performance-friendly way in a single user mode. That's why profiling is very important prerequisite for any kind of other load tests. Simply because profiling is a way of a dynamic code analysis that helps you to make sure that your system functions, methods, and components are responsive in a good way. If you are using Visual Studio LM as our case, you can attain this using web performance tests and unit performance tests. So what is load testing? Load testing is a kind of test that tries to make sure that your system capacity can stand still in front of certain amount of expected load, along with that apply certain amount of types of transactions over certain duration time. And over this experience, you have to make sure, the main goal is to make sure that your system resources are doing well in front of that load. Endurance testing could be considered as one of the subtypes of load testing, simply because endurance testing checks the sustainability ability of your system to stand still over a high spectrum of the expected load pattern of your system. One of the good examples that we need to apply endurance testing in was our case for the web-based system, simply because we wanted to make sure that our system can tolerate the load at least for 48 hours continuously. Another kind of performance testing is stress testing. And if we are talking about that load testing, is main objective is to test the system ability to sustain a load within an expected amount of users. Stress testing main objective is to test the ability of your system to sustain a load beyond the expected amount of users. And this is sometimes tagged as a negative testing. A good example for systems that needs stress testing all the time, banking solutions. At the first 3 days of Egyptian revolution, all people hurried up to whatever kind of ATM machines to withdraw whatever available cash in, simply because they were worried about the next coming of days. So these banking solutions that experienced earlier stress testing was ready to tolerate this abnormal kind of load. But the ones that never experienced a stress test have failed to fulfill their function. A subtype of a stress test is spike testing. And the spike testing tries to check the system ability of tolerating a sudden increase of users beyond the expected amount for repeated short durations of times. One good example for system that needs spike testing is stock market exchange trading systems, simply because most commonly the stock market trading sessions used to be 4 or 5 hours. But maybe at the end of the 4 or 5 hours, at the last 10 or 15 minutes, a simple piece of information will push floods of people, of buyers or sellers, to apply abnormal amount of transactions in the trading session. So spike testing will be helpful in that concern very much. So this was an essential background to conform the understanding together. So what was about our story? How did we accomplish our mission-critical history-making thing? At the beginning, I would like to review with you the very limited amount of resources that were in our hand to develop the solution and accomplish what kind of testing, including the load testing mission. We had only 2-month period to develop the whole thing, 6 developers, 1 project manager, 2 testers, SQL Server 2008, Visual Studio 2010 Ultimate, and some development machines, production servers, and nothing more. Due to the fact that we had Visual Studio Ultimate 2010, we decided to apply the load test using Visual Studio load testing. So let us see how the architecture of load testing works. You have your own client machines that create, edit, and execute the load tests. And this execution request goes to the test controller, who manages one or many load testing agent servers who are responsible of running the tests and generating specific amount of virtual user load. By this architecture, the load testing model can scale for high amount of users. So in order to accomplish our mission, we divided it into 6 main steps. First, defining the strategy based on which we will plan for our tests, then begin planning for our tests, then accomplishing the tests, and after that, we will analyze the results. And based on this analysis, we will find out the limiting resources that needs corrective actions to be applied over. And at the end, we applied what is called isolation testing to make sure that the corrected resource actually solved the load problem. So what was our testing strategy? We tried to make it very simple, but very clear, which was being proactive. According to University of Wisconsin-Madison, if you try to fix a bug at the end of the testing phase or at the beginning of production life cycle, you will pay 4 times more than catching this bug during development. And due to the fact that we didn't have the ledger of time, so we wanted not to stay to the time of load testing in order to find the load problem, simply because load testing is mainly about non-functional requirements. So if we will find load testing problems, it will not be easy to fix that kind of problems at the end. So being proactive meant for us 3 main things. First thing, that it's quite phenomenal that you cannot fix, you cannot assure that your system will stand still in front of certain amount of load for a certain amount of users unless you are sure first that your system can be responsive enough in a single user mode. So we applied a rule for every kind of developer that he should run his unit performance tests for developers who used to work in the back end, and web performance tests for people who used to work at the front end, to make sure that at least the dynamic, our code will pass through the dynamic analysis profiling correctly. And to ensure that this will happen and they will pass through this kind of tests, we had to make sure initially that no performance unfriendly kind of codes will be written inside our system. To make sure of that, we created some static analysis rules that try to make sure that no single line of code will be written in a performance unfriendly mode. For example, multi-threaded performance anti-patterns or bad practices of write data access code. But the main challenge that faced us during those days, or the main question that rose up at this time, was how to make sure that this will happen by every developer. Get it chicken was the good answer for that, which has first introduced in Visual Studio 2010. And for people who are not acquainted very much with Get it chicken, let us see how does it work. When a developer tries to check in his code to the source control TFS repository, the source control tries to send this code to something like a fake build server, and this build server applies whatever build tasks over this code, including the static code analysis, such as in our case, the unit tests and the profiling tests. So if these tests, the build server gone through it, it accepts the source control to check in the code, otherwise it will refuse it. So what about planning the test? How did we plan for our test? When we tried to plan for our test, we accomplished 6 main action items. First was to have an accurate calculation of the expected load of users, then to define our expected transactions or user stories and to pick them correctly, and to define our server resource thresholds that I will not be able to share every number about them due to the national security concerns and NDA that I'm signing. The fourth thing was to set up our testing environment. And when you try to prepare your load test environment, you have to make sure that it imitates the production environment, physical production environment, 100%. So in load test, you cannot use virtual environment simply because load test is about examining the system resources. So you have to have a 100% typical physical environment. And for the limited resources concerned, we decided to use the same production environment as our testing environment, simply because we were fortunate enough that the production time was not there yet. Then we chose our load test belt, and finally, we began to prepare our test data. And our testing database actually contained data about 55 million voters. And there was a separate a team who was responsible of preparing this database. So we were in a risk that maybe when we begin our load test, this team that is appointed to prepare this original 55 million voters database will not finishing filtering these records. And this was one of the most important factors in the whole elections process, simply because any discrepancy that could be discovered inside the database may hit in the whole credibility of the whole elections process. So we didn't want to rush them up, and we tried to mitigate with this risk by preparing a new what is called Plan B database using SQL Server data tools. Using SQL Server data tools, we succeeded to generate something like a fake 55 million voters data using the same regular expression that be used in the national IDs of Egyptian people. So in that way, we had two databases, the original one and the Plan B fake database are just a risk mitigation tool. So how did we calculate our expected amount of users? When you get to something like that, you have either to base your calculations over realistic facts or you have to assume. And in our case, we did something hybrid. This meant that we got to the phase 1 system, and we get the log servers data from it about the loads that the phase 1 system experienced. But because we know that the system was not doing well, we didn't stop here. But we took in our consideration some assumptions related to the cultural and demographic dimensions. What we did with those dimensions, the demographic dimension helped us to make sure about the distribution of load over the 24 hours in Egypt. So we found out, based on this data, that almost the internet usage in Egypt is distributed evenly over the 24 hours, simply because from 8 a.m. to 4 p.m., employees used to use internet massively, then from 4 to 12, housewives and households, and then from 12 a.m. till 8 a.m., Egyptian youth used to use internet, especially that the Egyptian universities' vacation, summer vacation, have begun at those times. The cultural dimension was very important because in the Egyptian culture, there is something that pushes people always to try to make sure that everything is going okay at the last minute. So we expected that at the last 48 hours, whatever amount of users have used the system before or not, we expected that every voter will get to the system at those last 48 hours to make sure that the voter center address has not changed. And the last decision was about whether should we begin our calculations based on the full 55 million users, which means we assume that 100% contribution of voters will happen, which is almost unrealistic in any kind of nations. Or to be more realistic and apply, to assume that certain amount of contribution rate will be there. In order to get a final solution for that, we decided to get back to the elections mission statement. And we find out that it begins with a very simple but important statement, which was to provide an equal opportunity to every Egyptian. And this meant for us that we have to give the opportunity for everyone equally. And thus, we decided to base our calculations on 100% contribution model, even if it will not happen. So we began with the 55 millions, and we divided this by the 48 hours. So we found that per minute, we expect 19,000 users. And based on the fact that the major user story take in average 5 minutes from any user. So in order to find out the total number of users that could be found at any certain moment on the system, we multiplied 5 by 19,000, and we got more than 95,000 users. Additionally, we had to calculate the expected bandwidth, which was an expected bottleneck for our system. And this was not complicated. We tried to measure the needed amount of bandwidth for single user and multiplied it by 95,000. And initially, a duplex 2-load balanced T3 lines were enough at this moment. Couple of concerns are important to be mentioned about the web and WinForm system. First, about the web-based online system, the load test has been conducted to assure the system scalability. We wanted to make sure that our bad experience in phase 1 will not be repeated again. While the WinForms, the main concern was to assure the system reliability and availability. Additionally, it was very important to make sure that no failures will happen in that concern for any single user. Why? Simply because any failure for any single user out of the 15,000 judges will mean that we will lose the result of full voting center. And this meant two important things. The first thing, which was crucial, was that if this would happen, the whole credibility of the whole election process would be killed out. The second thing, that losing one voting center meant to lose the efforts of standing up for 4, 5, or 6 hours from hundreds of people to post their vote, and this was not acceptable by any means. So what was our best practices and lessons learned during our load test experience? First, it was about how to pick your best load pattern to be used. I mean, which could be used when. And load pattern is the way that the load agent server generates the virtual user emulation load using it. In Visual Studio ALM, there are 3 types of load patterns. The first one is the constant load pattern. And constant load pattern idea is very simple, which is that when you begin the load test, the load will begin from 0 to a certain amount of users. In our case was 15,000, and stay fixed with this amount of time. So the constant load pattern helped us to apply our load test for the WinForm system. simply because the 15,000 judges were expected to get to the system in one single moment, and from zero amount of users, the system will experience increase to 15,000. So the constant load model was very helpful in the WinForm system. For the web-based online system, we used step load pattern, which is most commonly used in every kind of load test experiences. Load test pattern talks about that we begin our load test with initial user count that run for certain amount of time, and then it increases to another level of users. And this increase take amount of seconds that is called the step ramp time. And after increasing the number with a specific amount of user that is called step user count property, it stayed running for certain step duration period that is calculated by seconds. And the load test stay in this way happening till it reached the maximum user count. The step load pattern was very helpful for us in load testing our web-based online system. A special mentioning here needs to be dedicated to the step ramp time property, simply because all kind of properties for the step load pattern and constant load pattern are tunable through the load test wizard, except the step ramp time. In order to tune the step ramp time, you have to get to the load test editor, point to your load test pattern, right-click it, and go to the properties dialog where you will find the step ramp time to tune it. The third kind of load pattern is the goal-based pattern. And goal-based pattern resembles in many ways a step load pattern, except in that the main objective is not to reach a specific amount of users. Instead, the goal always is to reach a certain utilization amount for a specific limiting resources that typically to be CPU or memory. So you say that I would like to reach an 80% processing utilization percentage, and I would like to see how many users are created as a virtual load at that concern. Actually, a goal-based load pattern is very helpful in three ways. First, it could be used in comparing a run-to-run. Second, it could be used to reach a target throughput level on a specific server. But the third one was the one that made it very helpful for us, simply because it helped us to find out the required or needed number of agent servers in our load test experience. What do I mean by this? Actually, if you run your load test in high-scale mode like our experience, and you miscalculated the number of load agent servers that generate the virtual user load, you miscalculated, your load test will go through very smooth, but the performance counters will not be accurate. So to make sure that your load test in a high-scale mode like this experience will run successfully, you have to make sure that you are using a right number of load agent servers. And to do this, we have used goal-based pattern. So how can we tune the goal-based pattern, and how did we do the calculation? In order to tune the goal-based pattern, you cannot use the load test wizard, simply because load test wizard only tune the constant load and the step load only. So in order to be able to tune it, you have to use the constant or step load at the beginning from the wizard, and then when you get to the load test editor, you go to the properties window, to the patterns property, and you change it to be goal-based value. Once you change it to the goal-based value, you will find that the load test node will be a goal-based load pattern, and the whole properties in the properties window will get changed to be the goal-based properties. Special mentioning should be dedicated to the counter property that defines the countermeasure that you would like to set as your goal, and to the high end, which is the high end goal that you want this countermeasure to reach. And when you reach this high end value, you check the corresponding amount of generated users. By this way, we based our calculations over the agent server based on what I would like to call a prerequisite load test run that applied goal-based load pattern. So at the beginning, before applying whatever kind of load tests, we run the load test over the Windows and web-based servers at the beginning using a goal-based load pattern. And we made the main we knew that the main limiting resources on our agent servers is the CPU. So we run the goal-based load pattern with the counter of percentile of the CPU utilization with a high-end amount of 90%. So this tell me the corresponding amount of generated users when you work over this kind of agent servers machines up to 90% utilization over just 2 agent servers. And it is important here to mention that when you run such kind of experience, you have to make sure about the weighting of agent servers, because you may say that the distribution of virtual users will be distributed evenly. So 50% of the users will be generated from agent A and 50% will be from agent B, or 30%, 70%, whatever. But due to the fact that the machines, all agent servers machines were the same, so we distributed the weight evenly over the 2 agent servers. And we ran our load test and found that the corresponding amount of users in that experience were 16,000 users. This drove us to the result that we have, our agent server machine can support us up until 8,000 users. Then we did our math. We divided the 95,000 users over the 8,000, and we find out that for the web-based online system, we need 12 agent servers, while for the WinForm system, we needed just 2 agent servers. Then we began to prepare our load testing architecture that will use 12 agent servers for the web-based load test and 2 agent servers for the WinForms load test. So to conclude what I've said about the load test patterns, at the beginning, as I've said, and as a prerequisite, we use the goal-based load pattern just to make sure about the right amount of load agent server that we needed for the web-based and WinForms load testing. Then we applied step load pattern with 95,000 users over the web-based system, and constant load pattern with expected 15,000 users over the WinForms system. Then we ran the web-based load test for 2 hours and with the full load. And when the results gone fine, we continue that for 6 and then 12 hours. While for the Windows-based system, we did it just for 2 hours, simply because we didn't expect that the load will last for more than just 1 hour. And now, before getting to apply the load test for WinForms, a very important question has been arisen, which was, what will be the reported user stories in WinForms? Simply because when you run your load test, only two kinds of user stories could be included, either unit performance tests or web performance tests. But our system was not web-based. It was Windows-based. So how we will apply to include the user stories? We were in front of one of two choices. The first one, which is the documented one, is to consider the unit performance test as our reported user stories inside the load tests. And another one, which we innovated, was to write a fake web pages that calls the WCF services as if these are the user stories of us. And actually, we found that this solution will be more helpful simply because it gets you a control over the request counters in easier way. So what was about the test controller database? What is initially the test controller database? Test controller database is a SQL Server database that each Visual Studio load test controller used to run either on a SQL Express instance or over a standalone SQL Server instance that could be hosted locally or even remotely over a standalone data access server. And in order to make this happen, you get to the Manage Test Controller dialog and tune the test connection string for your standalone database server. What is important to be mentioned here, that when you run such kind of high-scale load test, you have to make sure that this database that used to include the performance counters of the whole testing experience will work good. Simply because it will not work good, your load test will fail for nothing but for that reason. And I can assure you, if the load test will fail at this time, you will not be able to find what is the reason unless you know about this. So in order to make this, we had to make sure that our testing database, the test controller database is a very good fitting machine by means of storage, processing, clocks, and memory. There is a way you can use it to control your database size and operations as well through set the timing property to none or statistics only. But this action will limit your ability of analysis afterwards. Simply because while it will give you, it will keep the performance counters, but it will not include the detailed timing values for your load test. Instead, it will just include some average timing for your test. So if you need the detailed timing values for your load test counters, you shouldn't do that. Additionally, you have to go through controlling your log file size. And what is log file size? It's the place where performance counter samples and error information are being stored. And it's the same like the database. If you cannot control the log file size that could expand to gigs of bytes as well as the database, you will lose the control over your machine and thus the load test experience may fail. So to control the log file size, you have three actions that you can choose from. The first thing is to specify how frequently you would like to save the log during your load test runs. This means that I want to log the test runs, one test per 10, one test per 5, one test per 3, so on and so forth. And to attain this, you get to the load test editor, run test node, right-click it, and then get to property that tells you about the frequency of load tests that you would like to log. So the number here, if we were write, for example, 10, this means that one of each 10 tests will be logged, and this means 10% of the tests will be logs only. Or you can switch the test failure logging on or off, or you can set a maximum ceiling function for your system log file size. In order to do this, you have to get to the QTC controller configuration file that is placed under the IDE subfolder and get to the attribute that is called log size limits in megs, which is by default is 20 megabytes, which is nothing, in our experience, was nothing, because the file expanded to gigs of bytes, and you set it as you would like. Caching data. And when we talk about caching data, we have two kinds of data to be cached. First, the web pages, the resources, the images, the text, everything. And you need to make sure that your web pages resources are not being cached. Because if they will get cached as if the 95,000 users are the same 95,000 users always, your test result performance counters will not be realistic. So we wanted to make sure that every 95,000 users could be considered as totally new 95,000 users. And to make this, we get to our scenario in the load test editor, right-click it, the properties, and opened the percentage of new users, which is by default 0. So take care about this, because if you will not fix this, your page's resources will be always by default cached, and thus mean that you will be faked out simply because the load test will run successfully, but the performance counters will not be realistic. So in our case, we do it as 100%. The second kind of load test data was our data that will be used in our data-driven tests, which was the national IDs. And national IDs in the States resemble the Social Security number. So we were fortunate enough that by the time of beginning the load test, we had our database, the original database ready. So we combined up the 55 million, original 55 million IDs, along with the 55 faked IDs. So we got 110 million IDs, and we made sure that every 95,000 IDs are new IDs. So we made sure by this way that the response data will not be cached by any way. Security. And when we talk about security, you have to make sure that your load test files and load test results are not shareable with anybody, simply because those kind of results and files could potentially contain a potentially sensitive amount of data that could be a perfect tool to build an attack against your system. So be cautious and never, ever share it with anybody ever. And the analysis time began. At this time, we used load test analyzer. And I would like to mention just one tip here, that when you lose a load test analyzer, you will find that the results are being depicted while the load test didn't finish yet. This is good, but not good in the goal-based pattern case, simply because any kind of results before finishing the goal-based load pattern are not realistic, simply because the goal has not been attained yet. So no one can make sure that the results will be that accurate. After analyzing our results, we found that the main limiting resources are first CPU, then our IOs. And based on the fact that our system, 80% of the written code was sequential, while only 20% of it was multi-threaded. And based on the Admiral's law that tries to calculate for you the speed up increase when you increase the amount of processors from a number to another number. In our case, the servers contain 4 servers, 4 CPUs per server. So when we calculated based on Admiral's law, we found that doubling up the number from 4 to 8 will give us only a 3% performance increase, which was not satisfactory by any meaning for us. So we decided to not invest our time or money in such concern, and we dedicated our concentration to the IOs. One opinion was to place everything over an SSD drive, which meant a hell amount of money, which we couldn't tolerate it. So an innovative solution was to only place the SQL Server indices over the SSD drives while keeping the rest of the data files over our SAN storage systems. And by this way, we enhanced the search performance massively, and actually this helped us a lot in our performance counters back again in the isolation testing. Additionally, we were fortunate enough to have an extra bandwidth at the production time that helped us a lot. At the end, there were some other ALM practices that helped us during the whole development testing, development experience, not only the load testing experience. First, get the chicken didn't help us only to make sure that our system code will be performance friendly by the beginning of the load test, but also it helped us to save hell amount of time that we would experience it in some load failures that we might experience. Additionally, the product backlog was a very good practice for us, and we use the product backlog Excel sheet that comes with the Microsoft Scrum process template. It helped us to make sure that the load between the developers are distributed evenly and everyone is to the maximum, used to the maximum. And during that, we wish that the DevOps features would be there, which was not our case, because if they were there, we would find out what was wrong with phase 1 system and didn't need to repeat the thing from the early beginning. Currently, we are exploring how to use it in the subsequent elections. For more information about the user story, you can get to this address. And I would like to recommend for everyone to download and read this Patterns and Practices book, which is called Testing for Continuous Delivery with Visual Studio 2012, that covers many of the testing concerns beyond the load testing. This means that it doesn't cover the load testing, unfortunately. Last but not least, I would like to thank Brian Harry, Jeff Behler, and Darshan Desai, and along with Darshan's team for their outstanding support, care that they provided for us during such experience. And actually, this support happened even when the case study has been published. Brian has dedicated a full-page blog to talk about the success story. You can catch me over these contacts if you would like. Thank you for joining us today, and I'm open for any kind of questions offline. Thank you. Sure.
So you had a development environment to do your testing, which will never be the same as a production environment. How far were you from your estimate?
You mean using the testing environment and the production environment? Testing environment is totally different than the development environment.
Yeah, you were testing.
Yeah.
It's still different from the real environment.
No, in load test, when you apply load test, you have to make sure that your load test environment is typically the same of your production environment, simply because you are testing the load of the system when the real users will apply this kind of load over that system with this environment, with this architecture, with these server configuration resources. So you have to make sure that it's the same architecture, the same servers configurations, the same memory capacity, CPU capacity, storage capacity, whatever. So this is different than any other kind of testing, like functional testing, for instance, because in functional testing, you would like to make sure that your system functions are requirements have been fulfilled. And this has nothing to do with the resources. If the memory is 4 or 8 gigs or 32 or 64. But in load, the main concern is the system resources. So you have to make sure that they are the same.
So you monitor probably the counter during the real stuff. How far were you from when you did your test? Did you do the good estimation on the load and things like this? How did it
Yeah, as I mentioned earlier here, we tried to calculate them in a very detailed way, as I talked. Unfortunately, we reached, to be honest, we reached the minimum requested performance counter thresholds due to the limitations. But we reached it, but at the low end of it. But we reached it at the end. Thank you for joining us. I wish you to enjoy the summit. Thank you.